We want to determine whether this given function has a minimum or a maximum value, find the value of that minimum or maximum, and find the axis of symmetry. Well, what we have here is a quadratic function. I know that it's quadratic because the highest power on x is 2. Quadratic functions generally can be written as ax squared plus bx plus c. And quadratic functions either open upwards or they open downwards. And that depends on the value of a. If a is positive, then the quadratic function will open upwards. And if the a is negative, the quadratic function will open downwards. In this particular problem, we have an a value of 6. That falls into the positive category. So we have an upward opening parabola as our graph. And the question is, does that have a minimum or a maximum value? Well, it has a minimum. Right there at its vertex, we have a minimum value. And if the graph happened to open downwards like this, our vertex would be a maximum value of that graph. Okay, so we determined that this graph has a minimum. Let's find the value of that minimum. Now, there's more than one way to do this, but I think most students like to use a little shortcut formula that the vertex of a quadratic function or a parabola is located at the x value negative b over 2a. Now, what does that mean for our function? Well, we already said that a was 6. Here, b is 12, and we're given c is 10. So if we want to know where our vertex is located, we just plug in the b value and the a value from our particular graph. We have b equals 12 over 2 and a equals 6. You get negative 12 over 12 or negative 1 as the x value of our vertex. And if we wanted to look at a graph of what we've figured out so far, what we've learned is that this graph is going to be a parabola that opens upward, and its vertex is going to fall somewhere on this line, x equals negative 1. I know that the x value of my vertex is negative 1. So wherever we draw this thing, whether it's down here or here or here, the x value of our vertex falls along this line. We call this line an axis of symmetry, which is part of the question, and we'll talk about that again in a second. But what I want to do right now is I want to find where is this parabola located. In other words, where is the y value of its vertex? Let's scroll down a little bit to do that. So anytime we have an x value of a function and we want to find the y value of the function, we just have to plug that x value into the function. So we need to find our y value, which is f of negative 1. So where is our original function? It's 6x squared plus 12x plus 10. So I'm just plugging x equals negative 1 into our original function. I'm going to simplify. 6 minus 12 plus 10, if I'm not mistaken, is 4. So what do we know now about our graph? Well, we know that the x value of the vertex is negative 1, so it's going to fall over here, and the y value of the vertex is 4, and we know that this function opens upwards, so it's going to look something like that. So let's summarize. We found that our vertex is at the point negative 1, 4. That's this point right here. The minimum value of the function is that smallest value there. It's that y value here at the vertex, which is 4. And the axis of symmetry up here where our vertex was going to fall somewhere on this line, the equation of that line is x equals negative 1. So that is what we call our axis of symmetry. So I think that answers all of the questions. Let me scroll out here. So our function has a minimum value. The value of the minimum is 4. And the axis of symmetry is the equation x equals negative 1.